Welcome to Pomodoro Joe for Sunday, January 22nd, 2023. Today we're doing LeetCode problem 131, Palindrome Partitioning. This is a medium problem. The problem statement says, given a string S, partition S such that every substring of the partition is a palindrome. Return all possible palindrome partitioning of S. It's a lot to comprehend, so let's take a look at the example. In the example, they have a string AAB, and then the output is an array of two lists, one that has elements A, and B, and one that has elements A, and B. So it looks like we need to essentially use every character in our input string, find all of the combinations of palindromes, and return those as lists. Okay, so we will set 25 minutes on the Pomodoro timer and get started. So we'll have some result, which will be a list, and we will return that result. And I think I'll approach this using recursion for our first attempt. Okay, so with recursion, we'll need our base case. So let's see, we'll have two things we want to consider. If the length of our input string is equal to 1, then we can just return our input string. But we can't just return a string. We have to return a list of lists. So we'll have to wrap this string in a list of lists. It didn't work out as well as I hoped. Let's see. There we go. What else do we need to do? Well, we'll need some function that will help us determine if something is a palindrome. So we'll create isPalindrome. Let's see. IsPalindrome, it will take some string, I'll call it P. And in Python, this is actually super easy. You can just return if P is equal to the reverse of P. And you can just reverse by slicing and taking steps of -1. So that's our isPalindrome helper function. Next, let's just say if this entire string is a palindrome, we'll want to include that. So if we have some input string, and that input string, let's see, is palindrome, then our result, we will append our whole string. But again, we need to wrap it in a list. Okay, so that takes care of our main base case and then our one edge case where the entire string is a palindrome. Now for the rest of this, we will slice off the front or the left side of the string, check for palindromes, and then pass the rest of the string as a new string to a recursive call to partition. That looks like this. So for our index in range length of S, so this is the sort of end index. We'll be saying the first part of our string is equal to our string up to that index. Up to that index. And we need to add 1 because that is not inclusive, so we need to add 1 here. So that'll be the first part of our string. The remainder of our string will be essentially from index 1. That's the first part of our string. The remainder of our string will be from our index forward. So we'll call, let's see, what are our, I'll call it remaining palindromes. And that we can get by just calling the recursive function. Let's see, partition on our string from index +1 to the end. Okay. Then let's see. We actually only need to call this if our first is a palindrome, if the first part of our string is a palindrome, so we'll check that first. Let's say if it's not a palindrome, then we'll just continue. We don't need to do anything. Okay. Otherwise, we will call the recurse, and then we'll say for option in remaining palindromes. Actually, I'll just call it remaining palindrome in remaining palindromes. We can just say the result. We'll just append our first. We'll have to wrap it and then append our remaining palindrome. And that actually should cover it. I think we're done. Yeah, I think we're done. Let's run it. Okay, that passes. Now there's one edge case that I want to double check, and that's this one where the entire thing is a palindrome. So let's create a custom case, and we'll just say AA, and we'll run that. All right, so that passes. So we'll submit this. I have a feeling it might not pass the runtime requirements, but we'll see what happens. Oh, and we do pass. This beats 45% of other algorithms for runtime, and it beats 83% for memory. So that's pretty decent memory footprint.